Hello everybody. This video is about hyperparameter tuning using GridSearchCV with decision tree regression in Jupyter notebook. Now let's go to Jupyter and start working. So the first thing we need to do is to read the data. For that we need a Pandas library. And then we need to load the data set. Let's call it my data equal pd.read underscore comma separated value parentheses quote. This is the directory where the data set is found. Let's call it ESLTech docs data, and the data set name is flat. So the flat.csv, close the quote, close also the parentheses. Here is capital T. So you run. So let's run. No such file. Okay. I see the problem. We need a colon here. Good. Sorry about that. So let's set the 6 to 7 to make our codes reproducible. And let's see what is in my data. Let's have an idea about the head. So this is what you have, the first rows of my data. You have time. This is area, the flooded area is our dependent variable or target. And the remaining 6 here are the features or explanatory variables or predictors. So you have relative humidity, RH, ET stands for evapotranspiration, E stands for precipitation, H stands for air temperature, SN is soil moisture, GHF is ground heat flux. So let's go to my data. Start my data.describe, and you see the descriptive statistic. This is what you have. So now let's prepare the output and input data. So our output data for target, let's call it y. So y equal to my data from my data. We needed to take valid array. So array. Here my data. Okay, so let's have an idea about the shape of y. And first 5 rows. Y dot head. Okay. Now let's have the input variables or editors or features. Let's call them x equal, from my data we need to dot time dates, and then the target variable, which is flight area. We set axis equal to 1. So let's have an idea about the shape of x. And it's 5 first rows. So these are explanatory variables or features. So at this level, normally we need to run the variance inflation factor and the scaling. We need to figure out which one of these features are highly correlated, and then that's through the variance inflation factor, and remove one of these, and then proceed to scaling before we split our data set. But for the sake of time, it's not in this video. I already have 2 videos, one about the VIF, variance inflation factor, and the other about scaling. So just look at it. So let's split our data set. Splitting the data set into training and testing data set. For this we need from scikit-learn dot model underscore selection. We need to import the function train underscore test underscore split. From scikit-learn dot model underscore selection. Train test split. Okay, and then splitting our data set. So we have x train, x test, y train, y test, equal to train underscore test underscore split. Want to split x, y. You want the test size. In this case, I put it to 25%, and the random state, I put it to 30. I want the operation to be shuffled, the data to be shuffled. So just shuffle equal to true. And run. let's count the shapes and see. Let's test that shape. White tail, that shape. Y tester, that shape. So this is what we have as shapes of our script data. So we needed to import. The next step is to import necessary functions and the libraries. So we need our decision tree regressor from scikit-learn dot tree import decision tree regressor. Then we need GridSearch itself with kfold from scikit-learn dot model underscore selection import GridSearchCV. We need kfold. We also need cross-value score. Then we need the metrics from scikit-learn dot metrics import R2 score mean absolute error mean squared error. We also need to import NumPy as NP, and from NumPy we need absolute. We need to suppress warning messages, so importing warnings function to ignore warning messages. So import warnings and then now warnings dot filter warnings, parentheses, code, ignore, close. Okay. Now we are going to start our work. So decision tree regression. It's base parameter search. Parameter search using GridSearchCV. Or if you want hyperparameter tuning with decision tree regression. Okay. So let's have our model. Decision tree regressor. Let's have the grid of the parameters. So decision tree params equal. Let's have the max depth. We need the parentheses, curly brackets. Let's open and close at the same time. So let's have a max depth. And max depth, what are the values? Let's have a 369. Take just 3 for the sake of time. Then let's have the mean sample slip. Set to 2, 3, 4. And the mean sample split. Up to 4, 6. I already take 3, but you need to take more for research purposes. This is for the video, but for your work, you really need to have more arguments and more values in order to have a good result. You would have a lot of combinations, then these combinations are going to give you good result. So let's add the main max leaf node. Let's have 50, 100 and 150. Sorry, 50, 100 and 150. Good. Okay. Now out of the curly brackets, let's have our cross validation So gently cost validation for k-fold parenthesis and split, number of splits. I take 5, you need to take 10. Cross validation 10 is better, but for the sake of the video, take 5. And random state. Here, take 1. Again, shuffle to true. Now let's have our object, research object for the decision tree. So let's call it DT. GridSearchCV. Our model. This is the first line. Then the parameters, DT params, DT underscore params, then cost validation equal DTCV, DT underscore CV, and the scoring equal negative mean squared error. You may take to negative mean absolute error as you want. So n jobs equal -1. Good. And now we need to fit dt dot fit. So the grid object dt here, we fit it. I fit it on the whole data set. Good. Okay, k-fold. Okay, random here. Random state. Good. It's running. You see here, it tells us that it's easy. It says random easy picket. Elapsed time. Okay, good. It's already done. So printing the best parameters and score. Print the best parameters are dt dot best underscore params underscore. Then we need the best score. Print the best score is dt dot best underscore score underscore. Okay. These are the best parameters. hyperparameters we have here. So we are going to take these best parameters to fit on to create a model and fit on training data and evaluate the performance on both training and testing data set. So modeling using the best parameters and the fitting on the training data set. So the initialization dt equal model first equal decision tree regression, and here we have max depth which is equal to 6, and the max leaf node nodes equal to 50, mean samples split, mean samples leaf, sorry, mean samples leaf equal to 2, then mean samples split equal to 6. So all many try. Mere max depth equals 6 max leaf nodes equal to 50, mean samples leaf equal to 2, mean samples split equals 6. Okay, good. This is our model. We are going to fit it on the training data set. So let's put decision tree for model dot fit x train y train. Now we are going to evaluate the performance on the training data set. Performance evaluation on the training data set. We first need to predict it, so let's call it dt pred entier equal dt dot predict on x train. So once you predict it on x train, we now want to have an idea about the R square and the MAE and the MSE as well. So we print the training per square is dt r2 square r2 score and y train and its corresponding predicted value, which is dt dot pred tr, dt underscore pred tr. So y train and the predicted value. We want the score. Underscore score. Okay, it's a comma here instead of point. Good. Sorry for the typo. And then we print the training mean absolute error is mean absolute error of y train and its corresponding predicted value, which is dt underscore pred tr. And the MSC, the training MSC is mean squared error of the observed and the predicted pred tr y. Good. Let's evaluate the performance of the model on the testing dataset. So dt pred ts this time, prediction of the test dataset, equal dt dot predict on x test. Predict. Typo here. Sorry about that. So let's print the r square, the testing r square is r2 underscore score for the observed, and sorry, the observed here is y test, and dt underscore red ts. So 0.80%, and it was 85 on 10 data set. It's about okay. Let's have an idea about. Let's take the pancreas. 2 digits after the decimals. Let's take off comma. Okay, 0.81 exactly. Okay, let's print the testing 98E equal mean absolute error of y test and dt red ts. Let's print the testing MSE squared. Okay, so this is the performance on training and testing. Now let's run the k-fold cross validation and see. Let's add more cells below. Okay, fold cross validation. And the training data set. Let's call it GridSearchCV. Cross val score dt x train y train scoring equal negative mean squared error CV equal, I take 5 again for the sake of time. Run. We need the mean absolute. Mean CV error. So we print the training absolute mean cross validation score is absolute. Take NP numpy dot mean. We need the mean of DTCV. So this is telling us normally this. Let's add a cell below. If you type DT underscore CV here, this is what you get. Have 5 columns of data, 1 row. So for each of the fold, you have a data. They are all negative because of the negative here. So you need now to bring them positive and just take 1. So the mean of all the 5 and put in absolute value. Okay, so now let's have it on the testing data set. Okay. Let's call this CVTR. We'll put here CVTR. Okay, let's run this. Okay. Now for testing, we call it DT CVTS equal cross val underscore score DT X test Y test scoring equal to negative mean squared error and the number of fold equal to 5. So let's have the mean. Testing absolute mean CV score and the testing absolute mean cross validation score is absolute of numpy that mean of our DT underscore CVTS. tree. Okay, so we are good with the cross validation, the K4 cross validation and the training and testing data set. Now let's have an idea about the plots, prediction, error, and residuals. So plotting the residuals and the prediction error. So you need to install yellow brick. So you go to Conda. I use it in Conda. You can use PIP and CMD as well. So Conda, install Conda underscore Conda dash forge 2:0 brick. This is the spelling. Conda install, yes, Conda dash forge yellow brick. You need to do that. Anaconda. Or you go to command prompt and PIP install. I think PIP install your bit. Okay. So let's plot the residuals. For yellow brick dot regression import residuals plot. And then you have the visualizer, which is equal to residuals plot of our model DT. Residuals plot of DT. Now we need to fit it. Visualizer.fit. Of course, we fit it on X trail and Y trail. Can do it on test as well. And we find the score. So for the prediction on text here on train, and we have the visualizer dot score on the testing data set, so X test and Y test. And let us proof it. Visualizer.proof. So this is the prediction, the residuals for the decision tree regression model. So here we have our training R square and testing R square here. So we just fit on X train, Y train, and have the scores here. On the prediction, for the prediction error, we can change. We can fit on X test as well. If you want to see the score of X test, So now let's go to the prediction error plot from yellow brick dot regressor import a prediction error. Have our visualizer equal to visualizer. So prediction error of the model DT. Now let's fit it. Visualizer dot fit and X-train Y-train visualizer dot score on X test and Y test. So you see here the R square here is for testing data set. So we can put here train on a train. That way you will have R square of the training. So now we have R square of the training data sets here. So that's what I said before. Fit on train, find the score on train. That's for the training data set. Fit on train, you find the score on testing data set. While above here, we get fit on train and find the score on the testing data set. So now we are going to have the plot of the predicted and observed against predicted. Here what you need also to do is, if you see that you have problem running the codes, go to from scikit-learn dot processing import standard scaler. If you run the code below, it doesn't work, probably you need this. So from scikit-learn.processing import standard scaler and everything will be fine below. So let's now plotting the observed against the predicted data. We need to import matplotlib lib.pyplot as PLT for this purpose. So let's do it for the training data set as well as the testing. So let's set the boundaries and the characteristics of the plot. Let's have fig x equal to have the subplots. So plt dot subplots. Okay. So let's have x. Let's have the scatter plot. Scatter of white rain, and it's predicted. Its corresponding predicted value. We call it dt. Predict, yeah. Yep. Close parenthesis. Now let's have the plot of the mean and the max for white rain. That mean and white rain dot max. That's going to give us the line of best fit. Again, white rain that mean white rain dot max. Let's have the color of the line as dark with 2 dashes, and the line width of the line, let's have it as 4. So this is the line of best fit. Okay, let's label. Labeling the plot. Let's have the x label, x.set underscore x label. Let's have observe flooded area. In squared kilometer. typo here is observed. Okay. Now x dot set y level or predicted. And square kilometer error. Predicted flooded area in square kilometer here. Let's have the title, PLT the title. Observe, Francis, predicted, flooded area. Training, let's put it training. Let's have a PLT dot show. Finish everything. So this is what you have in the plot. The predicted observe against predicted. So if you want on the testing data set, you just need to change everything here where all the train, wherever you have train here, we change it into test. It's going to give us on the training, on the testing data set. So let's copy and paste it here, and let's change training by testing. So let's have here y test, the predicted, the prediction of y test, 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 that is, and the testing. I think this is all you need. Yep. So this is observe against predicted. Now we want to plot observe and predicted. Plotting the observed and predicted data. So, as usual, you need to set the boundaries and characteristics. Boundaries and characteristics. Okay. So we need plt.rc params. Here's the figure size we need. So figure graphic size quotes in the parentheses, quote in the brackets, and we need it to be 10 and 6. Hyperparameters. Hyperparameters. Bracket quotes. Okay, it's here. Fig size. Fig size. Good. Sorry for the typo. So from ax equal, we take the range of the length of x test. Okay, this is on the testing data set, so we take x train. Put it here in the training data set. Okay, so PRT dot plot x, so this train length x train, and then you have y, so y train, not x, y train, so we have y train. We have the label, which is observe, and the color equal to dark, line style equal to dash, and line width equal to 1.5, and also PLT. This is going to plot the observe data, and the second line is going to plot the predicted y. So x x dt underscore pred tr. This is the predicted, the corresponding predicted value of y. Label is predicted. Color, let's give it blue color. Line style, line style, line style, line style, equal to 2 dashes, line width, let's say 1.2. Let's go for, okay, this is what you have. So in dark color you have the observed, and the blue color the predicted, both of them on the same plot, the same graph. So let's label clarity dot y label flat area square kilometer. The PLT dot x label is called training sample. Training sample data. Okay, let's have a legend. PLT dot legend. Boundary box to anchor equal 0.5, let's say negative 0.2 on y, x 0.5 here, just shift, and y a little bit below, negative 0.2. Okay, and then now let's have the location where we want the legend to be. Lower center, number of columns. We just need two, one for observed, the other for predicted. Then we need a frame around the legend. No, so we set to false. So this is our link. Lower center location. PLT.agent plus cancel location. Okay, let's go with PLT.show. Okay, so this is for the training data set. If you want for the testing data set, you just change again everything here, wherever you have trained by test. So let me copy and paste it below. Test, and here yes. Testing sample. Let's put here -2. Here, I think that's -2. Good. So it was 2, that's why you could not see the legend here. So -2, not push it below. So y should be -2 for us. To go down, let's see the legend. It was 2. Y was 2, so above. So now it's below. So here, this is testing. That's okay now. So thank you very much for watching this video on grid search hyperparameter tuning using grid search with this decision tree regression. I hope this video will help some people who are doing research. And as I said before, you need to set your cross-validation CV to 10 instead of 5. I'll put it 5 just for the sake of time, but yeah, you need to put everything to 10 if you are doing research. So you need to put it at 10, and yeah, the scores here, instead of 5 you need 10. And for the grid search as well, you need a 10 here, and put as many as parameters here for you to have good result. So hopefully this video will help some people in progressing in their research. Thank you for watching.